Alright, we're going to try to code up Conway's Game of Life as quick as we can before I have to go to work today. So I'm going to open a new project. We're going to be doing this in Monogame 3.8, which is a version of Monogame that just came out. We'll do this just across platform with OpenGL. We're gonna keep it simple and we're gonna put everything in one class, in the game class. Because, you know, we like to do that. Alright, so we're gonna need private texture. We're going to draw it straight to one texture, like each cell. I'm not gonna go into how, like, what Conway's Game of Life is because you should know that already. Alright, so we're gonna just call it texture. Alright, and each cell is going to be represented by a 2D array. Not a bool, but a bool. So either dead or alive, true or false. And it's going to be a 2D array. Cell, we're going to call this state. Or just state. And then private bool. We're going to need another one to like set the next, or set the current state to the next, because you have to calculate the whole state separate from the current, because if we keep editing each cell for this one, it'll mess it up, because it looks at the neighbor cells, and if those are constantly changing, then that's no good. So you're gonna draw this, and then we're gonna set this, and then set this to this, and then draw this again each frame. Alright, and we're gonna do some constants. So int const. Let's do x maybe, like width of the texture. Width is going to be, we'll just do 100. Yeah, I did that backwards. Const int width, and we're gonna do the same thing for height. And that's going to be the width and height of our texture, so how many cells, so 100 cells by 100 cells. And we're going to initialize those. So texture is going to be, oh wait. Never mind, okay. Texture is going to be equal to new texture, 2D, and pass in the graphics device. And then the width is going to be width, all caps, and height, all caps. We're going to close that out. Okay, so we have an empty texture now, and we're going to set state to equal a new bool array of width, comma height. Wait, it does rows, so height, comma width. Yeah, okay, and we're going to duplicate that, and we're going to do the same thing for next state, like dot. Alright, I think that is all we need to begin. Maybe we should we'll just have it update every frame. We don't need to do anything super fancy. We're going to go ahead and do our sprite batch now. Sprite batch.begin. We're going to do sampler state equal to point clamp because we want everything to be pixel perfect. Duh. We're going to close it out. I'm going to end that sprite batch here. We'll draw everything in here. I'll just put this stuff in here just in case you're a beginner. And then this is your update logic area. I'm sweating right now because I drank a bunch of caffeine. I'm gonna have another couple sips now. I don't know how loud the music and stuff is compared to my voice, but I know the mic is right next to the keyboard, so I might have to put ASMR in the title. Okay. Load content. This could have gone into load content. It doesn't matter, but we're just going to put it in load content. Just because we have a texture that we're going to do, and we're going to do the... I don't know why I'm doing that. It doesn't matter. Basically, the initialize runs once, and this runs once before load content is ran, and load content is ran once when you open up the game, and then update is around every single frame, and then draw is updated every single frame too. Alright, so we want to randomize, we need to randomize these first. So we need like crazy dots everywhere. We're gonna draw the texture actually right away. So we're gonna do sprite batch dot draw texture, because it takes in a texture, and then a rectangle for the destination. But we're just gonna do vector 2 and keep the size, which is 100 pixels by 100. And no, we're gonna do a rectangle so we can stretch it. Basically, if you didn't use a rectangle, it would just be the size of the actual texture you made, so 100 by 100 pixels. But you can stretch that so it takes up more of the screen, because that might be too small. We're going to put it up at the top left, so 0, 0, and then we're going to do, let's just do the width times like 3, and then height times 3. Yeah, and then color.white, which is a tint. And we don't need to tint the colors anything, so it'll just be black and white when we get to actually setting the texture. Whew. Okay. My brain's trying to go fast, but it's not built to go fast. All right. Next up, we're going to randomize. We're going to create a function for randomizing these cells. So public void, we don't even need it to be public. We can just do private. Private void randomize cells, capital C, so we can actually read it. And we're going to set random states for both of these, because we're going to just do them at the same time because it's starting. And then they'll both be the same state, and then we'll calculate the next state and set it equal to next state, and then draw it after we set that to that. All right, mouthful. I'm not good at stringing words together, apparently. Okay, so we're gonna loop through each of loop through the cells. So, and the way that 2D arrays work, we can get the width and the height using different lengths. So if we did state.length like that, that'll get the total, so 100 times 100. But we want to just get rows first, because we want to use these. So the first index, so the dimension 0, is going to be the first index, this index. And the way this works is it sets up like a grid. So, what the hell is that? It's like a grid, basically. Could have just did that. But it's like that, so when you create a 2D array, it's creating this little thingy, to visualize it. It's basically like a list of lists, or like an array of arrays. And so the first one is going to be how many rows it is. So like this would be an array of 3, 5. So you like saying get length gets all of these, and then or just length gets all of these, and then get length 0 gets just these 3, like it will return 3, and then get length 1 will return 5. Okay, now that we got cleared up, we got to get rid of these. All right, easy peasy lemon squeezy. All right, now we're going to do a nested for loop, and we're going to change this one to R so we know that we're dealing with the rows, so height. And then we're going to nest this so we can loop through the columns next. Oh, shit. I mean poop. I didn't swear. All right, now we have, this is going to run, it's going to run this code inside this for loop, how many height, like for each row, and then keep a variable for what index it's on, and then the same thing for this code in here. I don't usually write comment code, so but I'm going to for this, maybe a little bit, not all the time. So we're gonna, okay, I'm getting ahead of myself. Let's just randomize these. Okay, so we're gonna need a random object so we can actually get random numbers. So we're gonna make a new random object called random, we'll just call it rand, is equal to new random. Boom. This just gets like, yeah, you'll see. We'll be able to get random values from it. Okay, and then we're gonna set each one to a random value. So we need a integer to store that value first, which is just gonna be a random value between 0 and 1, or either 0 or 1. So we're gonna make an int equal to rand, called randnum, and it's gonna be equal to nothing right now. And then we're in here, we're gonna say randnum is equal to random, which is our random object, or rand, which is our random object, to next. And then between, it says returns a non-negative random integer, but if whatever number we put in is the max value, but it's not going to return that max value, it'll do one less. So we want to go 2. So this is going to either return 0 or 1. Alright, so we're going to do if randnum is equal to true, or you could just say that, but just so we can visualize it, we're going to put true. Then we're going to run this code, and if it's not, oh wait, if it's 0, and then if it's not 0, it's going to run this code. And then so if random is 0, we're going to make that cell at r comma c, which is the index for state. We're going to say state r comma c, which is the iteration it's on, is going to be equal to true. And then we're going to duplicate that and set the next state too, because we want both of them to be equal at the first one, so we don't get any weird glitches. And then for if it's 1, we're going to set it to false, like that. So that's going to randomize our cells, but we still don't even have it drawing the. We need a way to like actually set the texture, because it doesn't do that automatically. Why would it? So we're going to make a private void, we're going to make a function for set texture, like that, and we're going to do that same nested for loop. So we're getting the rows, we're looping through the rows, and then looping through the columns. We know which one we're dealing with because we're calling the variable r and c, rows and columns. Like that. Alright, so we're going to say if the state is true, it's going to draw a black pixel. And then if not, we're going to draw if it's false, we're going to draw it white. And so we actually need a color array to set the texture to, and we're going to just make that up here. And we need this to be equal to new color array of a size of width times height, so the area, like that. Mouthful. My brain's running sweaty today. I hope you guys can see this good. Maybe I'll zoom in a little bit more. Okay, so we're just setting if the state is true, we're going to set it to the index of the color to black, and if it's false, we're going to set it to white. So we need if statements for this. So if state at RC, so think like coordinates of this 2D array is like a grid, and we're putting in the index because this is running each time. So it makes a variable and sets it to 0, and it's going to keep incrementing it by 1 over here, plus plus, as long as the iteration is less than the rows, and then over here it's going to iterate this up until it's equal to how many columns there are in the texture. Okay, now that we got that, we're going to do if it's equal to true, then colors. Oh, and we need another variable because we can't pass it. This isn't a 2D array, this is a normal one-dimensional array. So we're also going to need a iteration counter just to see how many times this code ran, not the nested, because we only know how many this ran and how many this ran. So we also need to keep track of the iteration for like a one-dimensional array. So we're going to do iter int iter, not in. And then each time this code runs, we're going to do iter plus plus, and it will give us, yeah. So colors at iter, so it's gonna, the first pass is gonna be 0, and then so on. Like if it runs again, it's gonna be 1. So iter is going to be equal to color dot black, and then we're going to do an else statement. So if this else means if this up here returns false, we're gonna run this code instead, and we're gonna do colors iter, passing in that variable, and then is equal to color dot white. And we could change these colors to whatever the hell we want. I like to do dark olive green and then antique white. I like those colors, so we're gonna do those colors. So we have a randomize cells function and a set textures function. We don't have a function to calculate next state, so we're gonna do that next. Woo! So private void get next state. So this is going to take in state, the state two-dimensional array, and get a next state, and then set next state to equal state, or set state to equal next state. So it's gonna keep doing that every frame. So we're gonna do another nested for loop. It's a lot of nested for loops. And we're gonna do state dot get length again, get that rows, and for like C, and state dot get length. You could save the width and the height and just put them there. I mean, I guess we could just say we could just do this because we already have this. But you do need to know that how to get the dimensions of a 2D array. So we're gonna go ahead and just send all of these to that, just so it's so much easier to read. And I think I did that backwards. Yeah, it's height. The rows are height, and then width. You don't have to do this. You could do it the other way if you want to, but it just saves you a little bit of typing unless you did it all first and want to change your mind. Cool, cool, cool. Then change this back to height. Okie dokie. Let's do it. Alright, so get next state. This is where the chunk of the code comes in, because we need to check each neighbor, like each cell's neighbor, and you have to put in rules because you can't do like a neighbor if it's the first one, there's no left neighbor, so we have to make sure we account for that or we're gonna get an error. So let me take another sip of caffeine. While the sound changes. Okay. Alright, so we're gonna write the code with errors first and then fix the errors. So we're gonna be checking, we're gonna be using a bunch of if statements. So actually first we need to count each neighbor. So we're gonna set, we're gonna make a variable called neighbors and set it equal to 0 up at the top. So we're going to every cell that's alive next to the cell that we're looking at, so RC, we're going to increment neighbors by 1. So if there's 3 surrounding tiles that are alive, neighbors is going to be equal to 3. And then based on that, we do rules whether it stays alive or dies in the next generation. So if state R, C, so to look at each neighbor beside, we're gonna have to like do like that, and then like so. So we're just gonna start with this there because we're gonna type it faster by just copying and pasting the line, and then editing each one. So if state RC is equal to true, neighbors plus plus. Simple, but that doesn't work yet because that's just checking the one cell. We need to do this 8 times because there's 8 neighbors, like that, and I like to separate them here. Because these ones are going to be, we're going to do these diagonals, and then these are going to be just like directly to the right, top, left, bottom. Okay, so we're going to look at the one to the right, the one to the left. That's not the left. One to the right, one to the left, top, or the bottom, I mean, and then 1 to the left, or to the bottom, to the top. Wow, I'm so confused right now. And then we're going to do diagonals, so we're going to do +1 here, and +1 here, and then -1 here, and then -1 here, and then +1 here, -1 here, and then -1 here, and then +1 here. Easy peasy. Now it's counting all the neighbors. So now we need to do the checks. So we need to make sure that it's not going to add 1 if it's already at the last one. If it's at the last row, there's no plus, like r plus. It will return index out of range if we do that. So here we're going to do if we don't do this. You can't put an if in the parameters for an if statement. We're going to do if r is less than height and the index, like the neighbor is true. And we're gonna do that for each one, but just think in your head like which you need to check. Sometimes it's easy to get this wrong. So this one is going to be subtracting, so we can't subtract 1 from 0, so we're going to make sure it's greater than 0. And then for this one is C. If C is less than width, columns is width, and then if C is greater than 0. And then for the diagonals, we're doing like the same thing, but for both. So we're gonna need 2 ands. So if r is less than height and C is less than width. And then this one is going to be if r is greater than 0 and C is greater than 0, because it's -1 on r, -1 on C. And then for this one, we're going to be r is less than height and C is greater than 0, because it's subtracting from Z. C, not Z. There's no Z here. Not a single Z. Alright. And then r is greater than 0 and C is less than width. I'm not a fast typer. That's what happens. This is what happens when I try to type fast. I mess up a bunch. Alright. That's a lot of code. I swear it's not that confusing. And there's probably a better way to do it. There's always a better way to do something. Alright, so now at the end of this, we're going to have this neighbor's value equal something, and it's going to equal how many neighbors there that are alive surrounding the cell. And we don't know yet whether the cell that we're looking at, so R, C, is even alive or dead. So, and we need to know that to base to get the next state. So, if the state that we're looking at, so state RC cola, is equal to true, then we're gonna run this rule set, and if not, we're gonna run this rule set. Very simple, very simple. Okay, so if the rules are, let's do rules. If state is alive, then it'll stay alive if neighbors is either 2 or 1. Anything below 2, if it has below 2 neighbors, it'll die. If it has above 2, it'll die. So if it's inside, I'm just gonna say this is like the symbol for inside. If it's within 2 to 3, and then the rules for if it's dead, if the cell is dead, then it becomes alive if neighbors is equal to exactly 3. I don't know why I'm going to put semicolons there, but I'm going to. Woo. Okay. So if the state is true, we're going to kill it. If it's greater than or less than 2. So if state R is true and neighbors is greater than 3, or this is the symbol for or neighbors is less than 2, then the next state, make sure you're setting the next state at the same index is going to equal, not double equal, is going to equal false, like that. And then here, this is if it's alive, or if it's dead already. If neighbors is equal to exactly 3, then the next state at R, C is equal to true. It's magic, there's birth in this game. Oh, okay, that's it. And then at the end of this get next state, we're gonna just set next state, or set state to next state, which there's for 2D arrays you can't just say this equals that. You have to use a special function called array.clone, and it creates a clone of the 2D array. I don't know why you can't, but you should be able to. But we're going to do that by saying state is equal to array dot clone. Is that not in, okay, it's not a static variable, hold on. Next state dot clone. Boop. Okay, and then we are going to get an error. It says cannot implicitly convert type bool to, or type object to bool, a 2D array of a bool. So we're gonna have to cast it. It's very simple. So cast it like that. So this just casting things, you can cast anything really, as long as it's compatible. You just put the type that you want in front of this. Now it's not gonna work for some things, so, but basically just like primitives, so like integers, bools, vectors, stuff like that. I don't know actually about vectors, but you can convert things to string with something else, and we don't even need to know that. So I don't even know why I mentioned that. All right, basically, we got this next state. So we have an error, like it's saying that it's unused. So this is actually not going to do anything because in the update it's empty, and then it draws an empty texture because we don't have it setting texture. We need to call these. We're going to call them based on certain things. So we want to hit the R key and then randomize the cells, and then just have it automatically play out each frame. So we're going to make a keyboard. We want to listen to the keyboard. So we're going to make a keyboard state and call it keys, I guess. No, just do key state like that, and then equal to keyboard dot get state. That gets the state every single frame for us. Now we can say we're also going to need a bool, because you'll see why. Bool R pressed. So to make a little listener for this key, simple key, we're going to do if key state dot is key down. So if this is going to return true every time, like every frame that it's down. So if it holds, we don't want it to do that though. We want it only to play out once. So keys.r. So if the keys.r is down, it's going to return true and then run this code. But we want it to run only once. So we have to lift up and press it again to get it to press again. So we're going to do and r is pressed equals false. So right now it starts off false. And then when we press it, we want to set r pressed to equal true. To equal true, like that. So as soon as we press R, it's gonna for one frame, it's gonna run this code, because then now this is gonna be true, and it needs to be false to run this. So we're also gonna do an else, because we need to be able to run it again. We need to set it back to false when we're not pressing R. So else if key state dot is key up keys dot r and r pressed is equal to true. So it shouldn't be true if it's not pressed. That needs to be a I don't know what it's called, To compare two values, you have to use double equal, and then to set a value, use one equal. So then we're going to set this equal to false, back to false. Okay, now we have all this space. We have all this space to write code that'll run once, and we're just going to call randomize cells when we press that R there, like that. All right, now we can randomize it, and then we'll make it so we can hold down a key to play it out. So we're gonna make if key state dot is key down. So we want this to be to run every frame that it's down. So we'll do keys. You can set this to whatever key you want, but I'm just gonna do enter. So it's going to run this code. So we're going to want to, these are the order matters. So we're going to want to get next state and then set the texture, and then it'll draw down here. It'll draw. So if I got this right, it should work perfectly fine. I hope. And if not, we'll get an error and we'll fix it and it'll be fine. I hope you enjoyed the music. I love this 24-hour radio of lo-fi. So right now you see we don't have a texture, but we should hit R and it does nothing. I did something wrong. Okay, outside the bounds of the array. That's good. So the height is actually, like, indexes start at 0 and height is 100 and width is 100. But the indexes start at 0. So we actually have to subtract 1 from these because that's just how it works. Make sure you get all of them. I know it's a confusing mess to look at, but if you want to figure out a way to make things look nicer, totally tell me exactly how you did it so I can copy you. I don't even care, though. I'm just gonna back up all this. Some people care what their code looks like. You can do whatever you want with it, though. Alright. Let me make sure I got all of them minus 1. Okay. Now let me make sure... Oh yeah, randomize cell, it doesn't set the texture after. So we're actually going to have to call set texture at the end. Or we can call it manually up in the update. We can just do over here. Like that. Oh, and we didn't actually even set the texture. We have a color array, an empty color array. But at the bottom of this, when we get that color array, we actually need to call capital T texture, that's our variable name, dot set texture, or set data. And that takes in a color array and sets each pixel of that to the color array in order. And we're gonna pass in colors. Like that. Pretty cool. Now hit randomize. We get a randomized grid. And boom, we get another error. That's so fun. What's going on? What was the... oh my goodness. Where's iter? Iter is equal to 10,000. That should be right. Maybe we had to set that to equal. What is going on? Hold on, guys. My brain's working slow. I swear it's working. It's just this index thing. Alright, so the problem is that we didn't set the iter back to 0 in the beginning, so it just kept adding to it. And so once it adds more than the colors index, then it's going to give us an index out of range. But we also have another problem, but I know why it does this. So it basically works, but there's a bunch of like weird glitches, and that's in the .clone. We actually have the .clone doesn't work exactly how we need it to. So we go and calculate the next state. We don't want to use .clone to set the states equal to each other. We're going to do another nested for loop like this, and then do height, and then for C is equal to length. We want width. We actually can't use R and C, so we're going to we'll use I and J. Almost had a perfect run, but nope. All right, now it's easy. We're going to do state I comma J is equal to next state I comma J. So this is we're directly setting it equal. We're looping through them to set these equal. And now if you run it, hit R, and then it's really slow for some reason. Hold on. Oh, okay. I think I put this inside of a for loop. So I put 2 other for loops inside of a for loop. We can't do that. You got, yeah, we need it outside of this whole thing, and you can see it's very much inside of that. So just move it 2 down, reformat it if you want. You can reformat it just by going over here, going to code cleanup, run code profile 1, and it'll push everything over. All right, now that's outside. So after all these for loops run, we're gonna, oh, you know, that's probably why. I think I set the state equal to next state in here, so that's not gonna work. So we can actually use the clone. I'm not gonna edit any of this out either. This is what developing is like for me. So state is equal to cast it bool 2D array of bools next states dot clone. Like that. Now hit run and watch the magic. If it doesn't work, I'm gonna cry. There you go. That's how you make Conway's Game of Life before work. It was a long road, but yeah, if you want to add functionality to like click on cells, that's some different programming, but we could do it if you want to. Anyways, thanks for watching and enjoying this lovely music with me. That's Conway's Game of Life in Monogame 3.8. It's a really fun program just to watch, especially when you start adding coloring effects. And if you want to add color effects, you can do that. All right, see you later.